Welcome back to Inorganic TUTOR'S Institute. In today's lecture, we are going to dive into two powerful concepts in coordinate geometry. And basically, that is the end of the topics under straight lines in coordinate geometry. And that is going to comprise of distance of a point from a line and equation of angle bisectors between two lines, right? So basically, this concept, they are not just theoretical, right? They have real life applications in engineering designs, robotics, architecture, and optimization problems. Okay, so basically, we are going to begin with the distance of a point from a line. Okay, so let's dive into it. Okay, so let's consider distance, say d of points p of coordinates, right? So consider distance, say d of points p with coordinates x1, y1 from a line, say ax plus by plus c equals 0, right? So with this information, then we can say that the distance of a point, from a line is given by absolute ax plus by plus c all over square root of a squared plus b squared, right? So this is the formula for distance of a point from a line, right? We all know this. Everybody knows this. But the reason why we are here is to derive this formula, then we will use it to solve problems. So let's consider this figure, right? This illustration. So consider this as x and this as y, right? We are saying that a distance of point P from a line, right? So we assume that this is the line, right? And there is another point. So this is the point x1, y1, and there is distance, right? D, which has a coordinate x and y, right? You know that this here is forming a right angle, right? And that is perpendicular, right? So we can trace this here, right? So we can see that this is something like a right angle, right? And so we see that this part is x minus x1, right? And then we have y minus y1 here. Okay, because this is a right angle, it is basically perpendicular, right? So this is the line, right? This is the line. So this becomes our line, which of course it's ax plus by plus c equals 0. Okay, so this is our line. So here, okay, so now let's try to find the gradient of this line, right? Of this line. So ax plus by plus c equals 0. So finding the gradient of this line, okay, let's try to make y the subject first, right? So making y the subject, we're going to have y equals negative a over b x minus c over b, right? So we can spot from here that y equals negative a over b x minus c over b. Let's consider this as equation 1. Okay, so we have this equation. Now let's compare this equation with the slope intercept form, right? So y equals mx plus c. So we consider that as equation 2. Now comparing equation 1 with equation 2, we can see that the gradient is equal to negative a over b. And that is the gradient for this line. Okay, the gradient for line as plus by plus c equals 0. That is the gradient here. Now, since this line is perpendicular to dp, is perpendicular to the line dp, then we can say that the gradient of dp, right, of which is going to be the negative reciprocal of the gradient of this line as plus by plus equals 0. Okay, the gradient of line dp is the negative reciprocal of m equals negative a over b, right? So now the gradient of line dp will be equal to negative reciprocal of this gradient that we obtain here, and that is negative 1 over negative a over b, right? And that is going to be b over a. Okay, now we have the gradient for this line dp. Okay, so that's the gradient of line dp is m equals b over a, right? So we have that down. So once we have the gradient of this line dp, then we can use the gradient of line dp to find the equation of the line segment. Okay, to find the equation of the line segment, and that is going to be and that is going to be y minus y1 equals m into x minus x1, right? Okay, now we have our gradient to be b over a, right? So we're going to have y minus y1 equals b over a into x minus x1, right? Now, let's try to make y the subject. So making y the subject, we have y equals b over a into x minus x1 plus y1, right? So we have this here, and then we have, so let's consider this as equation 2. Okay, so this and this are going to be very useful. This equation and this equation are going to be very useful. Okay, so basically, you know that this is y equals this, and this is also y equals that, right? So we can equate both equations and find one coordinate of the distance, which is the d, the coordinate of d, right? So equating 1 and 2 we're going to have b over a into x minus x1 plus y1 equals minus a over b x minus c over b, right? So we can make s the subject in here, right? So let's try to spread the b over a throughout this information here. So we're going to have b over a x minus b over a x1 plus y1 equals minus a over b x minus c over b. Okay, so trying to make s the subject here, we're going to have b over ax plus a over bx, and that should be equal to b over ax1 minus c over b minus y1, right? So here we can see that x is common to these two terms. So we factor x out. So we're going to have x into b over a plus a over b. And that should be equal to b over a x1 minus c over b minus y1. Okay, so let's try to sum this information here so that we can make s the subject from this. Okay, so let's try to sum that. So we find the LCM, and that is going to be AB, right? So this cancels this. We're going to have B times B, and that's going to be squared, plus this cancels this. So we're going to have A times A, right? So it's going to be A squared, right? So we're going to have X into A squared plus B squared over AB, right? And that is equal to B over A x1 minus c over b minus y1, right? We are interested in the x, right? So we can multiply here by ab, multiply every item here by ab. So we're going to have ab times x into a squared plus b squared over ab, and that should be equal to ab times b over a x1 minus ab times c over b minus ab y1, right? So this takes off this, and then we're going to have x into a squared plus b squared equals, this takes off this, so we're going to have b squared x1 minus this takes off this, so we have ac minus ab y1, right? So trying to make s the subject here, we divide here by a squared plus b squared, here by a squared plus b squared, right? So basically this cancels this, and then we're going to have x equals b squared x1 minus ac minus ab y1 all over a squared plus b squared, right? So this is the first coordinate for D, right? This is the first coordinate for D. So let's go ahead to find the second coordinate, which is the y coordinate. So we're going to make s the subject in this and make s the subject in this as well. Then we equate both, right, to find the coordinate of y. So let's try to do that here. So making s the subject from this equation, we're going to have, so let's try to eliminate this fraction first, right? So we have ay equals b into x minus x1 plus ay1, right? So we need x, right? So we have ay equals ab minus bx1 plus ay1, right? Trying to find x, this is where this is basically bx, right? Minus bx1, right? So trying to find x, then it means that we are going to send all this information here. So we're going to have bx1 minus ay1 plus ay, and that should be equal to bx, right? We need x, so we're going to have x equals bx1 minus ay1 plus ay, and that is over b, right? So this is what we have for making x the subject in this equation. So we have this here. Let's try to make x the subject in this as well. This is our earlier equation 1, right? So making x the subject in this as well, we're going to have y equals minus e over bx minus c over b, right? We need x, right? So what do? We can multiply. Okay, let's try to sum this, right? So summing this, meaning that b is a common denominator, right? So we have minus a x here minus c, right? So basically, we're going to have y equals minus ac minus c over b. Okay, so if you need x, then let's try to multiply through by b. So we have yb equals minus ax minus c. We are interested in the x, so we send this here and bring this here. So we're going to have is ax equals minus yb minus c. Okay, so we have x equals minus yb minus c over a, right? So this is what we have for x. So this is, let's say this is 3 and this is 4. So let's try to equate 3 and 4. So equating 3 and 4, we're going to have bx1 minus ay1 plus ay over b, and that should be equal to minus by minus c over a, right? So in here, we just need the variable y, right? So what can we do? We cross multiply, right? So we do that, we're going to have b into minus by minus c, and that is equal to a into bs1 minus ay1 plus ay plus ay, okay, plus ay here. So we try to spread this b here and spread this a here, okay? So we are going to have minus b squared y minus bc equals abx1 minus a squared y1 plus a squared y, right? We are interested in the y, okay? So what do? We can send this here, right? So let's try to do that and avoid negatives, right? So a squared y1 minus ab x1 minus bc equals a squared y plus b squared y. Okay, so we need y. So what do? We say that, okay, let's try to bring this here. A squared y plus b squared y equals a squared y1 minus ab s1 minus bc, right? So making y the subject in here, we factor y out. So we're going to have a squared plus b squared equals a squared y1 minus ab x1 minus bc, right? So we divide here by a squared plus b squared, here by a squared plus b squared, right? So this takes off this, and then we can say that y is equal to a squared y1 minus ab x1 minus bc all over a squared plus b squared. And this is the coordinates, the y coordinates of D. Okay. So now we have the y coordinate of D, and then we have the s coordinate of D. So when we combine these coordinates, then we have the coordinate of D. Okay. So so now once we have the coordinate of D and that of the coordinate of P, of which it was already given in the information, then so now the coordinate of D, which is D of x and y, is equal to D of x now is b squared x1 minus ab y1 minus ac all over a squared plus b squared, comma, this is the x of which we have here, and the y is here, a squared y1 minus ab x1 minus bc all over a squared plus b squared, right? So this is the coordinate for D. And then we know that P, of which is x1, y1, right? So now we can say that the distance, now the distance of line PD, right, all squared is equal to x1 minus x all squared plus y1 minus y all squared, right? From here, this is P and this is D, and we are following this coordinates, right? So this is P, D. So P and D, this is the coordinates x1, y1, and that of D is that and that, right? So now we are going to place this coordinate into this formula, right? Of which x is here, y is here, right? So this is going to look a little bit many, right? But it's going to be easy, right? We're going to simplify it to be very easy. So from here, we say that PD all squared is equal to, now we know that x1 minus x, of which we have here, b squared x1 minus ab y1 minus ac all over a squared plus b squared, right? Plus, of which this is all squared, okay? Plus y1 minus y, of which a squared y1 minus ab x1 minus bc all over a squared plus b squared, of which this is also all squared, right? Okay, so this is what we are going to simplify to get our distance of a point from a line. Okay, so from here, from here, we say that distance PD all squared is equal to, let's simplify that right in there. So we're going to have our x1 minus, this bracket, this negative is affecting everything in the bracket, right? So let's try to do that from there. So negative b squared x1 plus ab y1 plus ac, right? And that is all over a squared plus b squared all squared, right? Plus y1 minus a squared y1 minus, so it's going to be ab plus ab x1 plus bc all over a squared plus b squared, right? And this is all squared. Okay, so what do you see here? We can see that this here, we can try to make add these two elements, right? By taking this to this section, then we have one denominator, right? So we know that this is over 1 and this is over 1, right? So we have PD all squared, that is the distance PD, and that is equal to x1 minus b squared x1 plus ab y1 plus ac all over a squared plus b squared all squared, right? Plus, okay, I'm coming. So when we do that, we're going to have x1 into a squared plus b squared minus b squared x1 plus ab y1 plus ac all over a squared plus b squared all squared, right? Plus y1 into a squared plus b squared minus a squared y1 plus ab x1 plus bc all over a squared plus b squared, right? And this is all squared, right? So from here, we can see that we can do some factorization in here, right? So let's try to do more simplification, right? So from here, we can see that PD, distance PD is equal to, let's try to spread the x1 through this information. So we're going to have a squared x1 plus b squared x1 minus e squared x1 plus AB y1 plus AC all over A squared plus B squared all squared here, then plus A squared y1 plus B squared y1 minus A squared y1 plus AB x1 plus BC all over A squared plus B squared all squared, right? So this we have here, this B squared x1 and B squared x1, this can take all of this here, and over here to B squared y1 minus A squared y1, and then positive A squared y1 can go off, right? So we simplify the information that we have. So we're going to have PD all squared, that is equal to A squared x1 plus AB y1 plus AC all over A squared plus B squared all squared plus B squared y1 plus AB x1 plus BC all over A squared plus B squared all squared, right? So now the work is becoming more easier, right? So from here, we can say that because this is all squared, then we can separate the numerator from the denominator, right? So we have our PD, distance PD all squared, to be equal to A squared x1, right, plus ABY1 plus AC all squared all over A squared plus B squared all squared, right, plus B squared y1 plus AB x1 plus BC all squared, right? And that is all over A squared plus B squared all squared, right? So from this information, we can see that so from here, we can see that A is common to all these items, right? So we have A inside A x1 plus by1 plus C, and then this all squared, right? You know, when you expand this and you square all again, you return to this information, right? All over A squared plus B squared all squared, right? Plus, we do the same thing here. You can see that B is common to all the three terms. So we factor B out. Then we have by1 plus A x1 plus C all squared, right? All over. So this is all squared, right? All over A squared plus B squared all squared, right? So now what we can see is that this term here and this term here have the same denominator, right? So we combine the numerator and choose one denominator, right? So we're going to have PD all squared equals A into AX1 plus by1 plus c all squared plus b into by1 plus ax1 plus c all squared. Now all over a squared plus b squared all squared, right? So we continue from here. So we continue from here and we see that PD, right, equals, now we can see that this information right here is equal to the information we have right here, okay? So let's try to do this, okay? Let's try to distribute the exponent to all the terms here. So we're going to have PD equals a squared into ax1 plus by1 plus c all squared, right? You know, we have not changed the information, the same information, plus b squared into ax1 plus by1 plus c all squared. And this is all over a squared plus b squared all squared, right? So from here, we can see that we have factorized the information, right? So now we can see that the brackets, the informations in the two brackets are the same. So we can add their coefficient, right? So from here we have PD all squared equals a squared plus b squared, a squared plus b squared plus ax1 plus ax1 plus by1 plus c all squared, right? And that is over a squared plus b squared all squared, right? You know, this is factorization. Once the informations in the bracket are the same, then we combine these terms and then choose one of the brackets. So that is what we have here, okay? So we can see that this is 2 and this is 1. So we can clear this over here and lose one of this, right? So we're going to have PD, distance PD equals ax1 plus by1 plus c all squared over a squared plus b squared here, okay? So you see we are getting to have the formula for distance of a point from a line, right? So from here, we can notice something from this section. We are interested in the distance, right, of PD. So what do? We square root both sides, right? So square rooting both sides, this is going to be plus or minus, right? So this takes of this and this takes of this, right? So we're going to have PD equals plus or minus into ax1 plus by1 plus c all over a squared plus b squared, right? Very beautiful, right? So from here, we can say that PD, that the distance, equals plus or minus into ax1 plus by1 plus c all over a squared plus b squared, right? So this is what we have. So this plus or minus over here is basically telling us that we can use absolutes of ax1 plus by1 plus c, right? All over, we forget the square root. Square rooting both sides means that the square root is affecting both the numerator and denominator, right? So once there is a square here, this takes the numerator, and the denominator maintains the square root, right? So all over square root of a squared plus b squared, right? So this becomes the distance of a point from a line. So the reason why we always try to use absolute sign is because distance doesn't encourage negative value. So we use the absolute sign so that we restrict ourselves to positive numbers, right? Absolute contains negative and positive, right? But in this case, we'll be interested in the positive values because absolute or distance does not value negative numbers, because if you have negative, it means it's showing you direction, right? It's showing you direction, and you're not going to consider that negative. It's just showing that maybe it's moving from opposite direction, but we don't consider the negatives. That is why we value the absolute sign, right? So this is the formula for distance of a point from a line. So that's the formula of a point of for finding distance of a point from a line, right? So that is the process that we go through to derive the distance of a point from a line. Okay, so now let's take problem, okay, to basically clarify this formula, right? Okay, so now I know you are very happy about the derivation of the formula for finding the distance of a point from a line, right? So now nobody taught you how to derive the formula, right? But right here on Inorganic Tutors Institute, we show concepts. We go deep into concepts, not just solving problems, but we go deep into concepts, and then we make concept very clear. So now let's consider this problem one, right? Let's consider this problem one, okay, to clarify the concept, right? So find the distance of P with coordinate 3 and 2 from the line with equation 12s plus 5y minus 11 equals 0, right? So basically, this problem is telling us to find the distance of a line from a point, from a line, okay? So from here, let's say that the line is D, right? So let's say this is D, okay? So we are assuming that this is having distance PD, right? So that is going to be equal to the formula. Now we don't need to derive the formula anymore. So we have the formula here, that is absolute ax1 minus plus by1 plus c all over square root of a squared plus b squared, right? So we have this formula. look at the problem and let's identify the parameters, right? So this is the point, right? And this is the line. Okay, so from the point P of 3 and 2, we can say that those points are what we call the x1 and y1, right? They are what we call the x1, y1. Okay, so basically from here, that is what we call the point of x1 and y1, right? So x1 here is equal to 3 and y1 is equal to 2. Okay, so how do we get the A and the B? The A and the B is obtained from the equation, the line with equation 12x plus 5y minus 11. So 12x minus 11 equals 0. This here, let's say this is equation 1, okay? So we compare this with the slope-intercept form. No, we compare this with the general equation of a line, right? So that is ax plus by plus c equals 0, right? So this here is to this here is to this, and this here is to that. That is amazing, right? So basically, we can say that our A is equal to 12, our B is equal to 5, and our C is equal to minus 11, right? So we have all that we need to complete this problem, right? So we're going to have our distance. We're going to have our distance PD equals absolute. Now our A is 12, right? 12 into x1 is 3 plus our B is 5 of y1, of which is 2, and then our C is minus 11, all over square root of A squared, which is 5. What is the A? 12 squared, plus our B is 5. So 5 squared, right? So we have distance PD equals absolute of 12 times 3, and that is 36, right? Plus 5 times 2 is 10 minus 11, right? Absolute all over square root of 12 squared, 144, plus 5 squared, which is 25, right? So we're going to have our solution to be 36 plus 11 plus 10 minus 11 is absolute 35, right? All over square root of, 144 plus 25, okay? So that is going to be 169, right? 169. Okay, so we have distance PD to be equal to absolute of 35 over square root of 169 is 13, right? So we have 13 here. So basically, because this is absolute 35, it means that we are going to have negative 35 over 13 and positive 35 over 13. But we are talking about distance, so we consider the positive value, and that is going to be 35 over 13. So that is going to be 35 over 13. And this becomes the distance of P with 0.32 from the line with equation 12x minus 12x plus 5y minus 11 equals 0. That is what we have here. Okay, so that is basically the process. When you're given the point with coordinate, any coordinate that you know, with equation of the line, then this is the process that you go through. Let's consider problem 2, where we have been given the distance already, and we want to find the other point, right? So we want to find the set P of points which are at a distance that is square root of 5 from the line 2x minus y minus 4 equals 0. Okay, so basically this question is asking us to find the set P of points. Okay, so now how do we go about this problem? Right, so from here we have been given the distance, right? The distance d to be square root of 5. Okay, and the line has been given us 2x minus y minus 4 equals 0. Okay, now we know that the distance of a point from a line is giving us absolute ax plus by plus c over square root of a squared plus b squared, right? Okay, so how do we get this information a, b, and c? We can get it right from here. Okay, so comparing 2x minus y minus 4 equals 0 with ax plus by plus c equals 0, then we can say that our a equals 2, our b equals -1, and our c equals -4, right? So we have all these information. Right? So what we need to do is to substitute into this formula, of which our distance is giving us square root of 5, right? So we're going to have square root of 5 equals absolute A is 2. Here we don't know our x because we are interested in the set P of points, right? Plus B is -1, right? -1 y. Then our c is -4 over square root of a squared 2 squared plus b squared -1 squared, right? So we have square root of 5 to be equal to absolute 2x minus y minus 4 all over square root of, 2 squared is 4 plus -1 squared is 1, right? So basically this is going to give us square root of 5 equals 2x minus y minus 4 all over square root of 5, right? So we have this information, right? Okay, so what can we do? From here, we can simplify this equation, right? So you know that this is over 1, right? So we can cross here. Okay, so don't forget your absolute sign because you have to get two equations, right? So from here, we can say that square root of 5 times square root of 5 should be equal to absolute 2x minus y minus 4 right here. Okay, square root of 5 times square root of 5 is basically square root of 25, right? And that is equal to absolute 2x minus y minus 4, right? And this is basically 5, right? And that is equal to absolute 2x minus y minus 4, right? So you can see clearly that this absolute sign is telling you that you have two solutions, right? So this is telling you that you have two solutions, that is plus and minus, right? So this is basically telling you that you have plus or minus. So you're going to have into that, right? So we can say that our first set of point is going to be 2x minus y minus 4 equals positive 1, right? And then our second one is going to be negative into 2x minus y minus 4 equals 5. So basically, we can say that we have 2x minus y minus 4 equals negative 5, right? So let's do the necessary so here we can say that we have 2x minus y minus 4 equals negative 5, right? So we have 2x minus y minus 4 plus 5 equals 0. And then we can say that 2x minus y plus 1 equals 0. Okay? And with regards to equation 1, we can say that we have 2x minus y minus 4 minus 5 equals 0, right? So we have 2x minus y minus 9 equals 0. So these two equations are the set of P, are the set of points P with which are at the distance square root of 5. Okay, so equations, these two equations are the set P of points which are at a distance square root of 5 with the line 2x minus y, 2x minus y minus 4 equals 0. So that's the set of points P which are at a distance of square root of 5 is 2x minus y minus 9 equals 0 and 2x minus y plus 1 equals 0. And that is it, right? It's amazing. Now you've seen the processes and the strategies to answering questions regarding distance of a point from a line, right? You've seen the first problem and you see the second problem. So basically, these are the basic ways of asking questions regarding distance of a point from a line, right? So let's now continue with the equation of angle bisectors between two lines. The equation of angle bisectors between two. So with regards to equation of angle bisectors between two lines, let's say that we are considering two lines, okay? line 1 and line 2. So basically L1 and L2. Okay, so this is what I mean. So consider two lines. Okay, so the lines, consider the lines L1 and L2. Okay, and let B1 and B2, let B1 and B2 denote, let B1 and B2 denote the bisectors, of the angles, between L1 and L2, right? So suppose B1 and B2 form, what we call the locus of points, equidistance, from L1 and L2, and also B1 is perpendicular to B2. Then you let's now look at the illustration. Okay, let's look at the illustration of this information. So we are saying that L1 and L2, okay, are the lines, okay, and B1 and B2 represents the bisectors of the angles between L1 and L2. And we are supposing that B1 and B2 form the locus of points equidistance from L1 and L2, right? And B1 is perpendicular to B2. Now, before I illustrate the diagram, I want you to understand some basic terminologies, right, from this information. Okay, so you have to understand the term locus and what we mean by equidistance, right? So from theories, we know that locus is the set of all points, okay? Locus is basically the set of all points that satisfy a particular condition or rule. So basically, with regards to this one, we are saying that the locus of point, okay, locus of point equidistance from two lines is the set of all points that are equally distant from both lines, and this is exactly the angle bisector, right? Basically, if a line is equidistant from, say, L1 and L2, then what it simply says is that distance of a point from L1 is equal to distance of a point from L2. Let me say it again. If you are saying that a point is equidistant from a line L1 and L2, then basically distance of a point from L1 is equal to distance of a point from L2, right? So that is what you are going to use to illustrate the diagram for this particular concept. Let's illustrate the diagram to this concept. Okay, so let's say you have what we call the two-dimensional plane, X here, and you have your y here, right? Now, you draw a line, say here, and this is here, okay? So let's say this is L1 and this is L2, right? And we are saying that we are letting B1 and B2 denote the bisectors of the angles between L1 and L2. So let's assume that this is we are assuming that this is say B1 and this is say B2, right? That is what we said. B1 and B2 denote the bisectors of the angles between L1 and L2. Suppose B1 and B2 form the locus of point equidistant from L1 and L2, and also B1 is perpendicular to B2, B1 is perpendicular to B2, meaning that they have an angle that is 90 degrees, right? So we are going to use the distance of a point from a line formula, right, in here. So let's try to use that formula to uh, derive the formula for equation of angle bisectors between two lines. So we know that distance of a point from a line is given as ax plus by plus c absolute of that, right? All over a square root of a squared plus b squared, right? So we are saying that L1 and L2, L1 and L2, B1 and B2 denote the bisectors of the angles between L1 and L2. And B1 and B2 form the locus of point equidistance, right? So if it is equidistance, then meaning that the distance of points L1 is equal to the distance of point L2, right? So let's say this is L1. The distance of point L1 is equal to absolute A1x A1x plus B1y plus C1 absolute, right? All over square root of A1 squared plus B1 squared, right? So this is the distance for the first line, the L1. Okay, now let's look at the distance for L2. Okay, so for L2, we say that absolute A2x plus B2y plus C2 all over square root of A2 squared plus B2 squared, right? And we are saying that L1 is equidistant to L2. So meaning that the distance of point L1 is equal to the distance of point L2, right? So we say that L1 is equal to L2, and that is equal to absolute A2x plus B2y. Okay, let's try to bring this first, right? So A1x plus B1y plus C1 absolute of that all over square root of A squared plus B1 squared, right? And that should be equal to absolute of this, right? Absolute A2x plus B2y plus C2 all over square root of A2 squared plus B2 squared, right? So since we are basing on the equidistance, the term equidistance to do this, right? So this is equal to that, right? So let's try to do this analogy. Let's try to do this analogy. So let's try to maintain the diagram for the meantime. So absolute a1x plus b1y plus c1 absolute all over square root of a squared plus b squared equals absolute a2x plus b2y plus c2 all over square root of a2 squared plus b2 squared, right? So here we can boldly say that because this is absolute, then it means that we have plus or minus, right? So we can say that we have a1 x plus b1 y plus c1 all over square root of a1 squared plus b1 squared equals plus or minus into a2x plus b2y plus c2 all over square root of a2 squared plus b2 squared, right? So this is what we have now. So we can either have a positive side of the formula and then we can have a negative side of the formula, right? That is what this is trying to tell us, right? So from here, this positive sign and the negative sign is telling us that we have both internal and external line, right? And when we are talking about equation of angle bisectors between two lines, we are the angles that involves in these two equation of angle bisectors, right, are two. It can either have acute or obtuse angle. So the angle that forms here, okay, can either be an acute angle or obtuse. And the one that forms here will also either be acute or obtuse. So basically, when you are talking about equation of angle bisectors between two lines, the angles that falls between the distance, these two lines can either be acute or obtuse. Same thing applies here, right? Now, what is acute angle? We learned acute angle from the previous lesson, right? Acute angle lies between 0 and 90 degrees, right? And then obtuse lies between 90 and 180, right? So it's either line 1 has an angle of line 1, the angle between L1 and L2 here is acute or obtuse, or the angle that forms here is acute or obtuse. That is why we are having this formula. Okay, so this is the formula for finding the equation of angle bisectors between two lines. The equation of angle bisectors between two lines. Don't forget, this is plus or minus. So always you have two equations, okay? Because you are having two lines. Each line has an equation, a linear equation. right? So each line will have a linear equation. Okay, so that is why we are having plus or minus. Okay, so let's take a problem to basically clarify this concept. Okay, let's take a problem to clarify this concept. Now let's try to solve this particular problem, okay, so that we can end the concept. Okay, so find the equation of the lines which bisect the angles between the lines x plus y equals plus 2 equals 0 and x plus 7y plus 26 equals 0. Okay, so in here we let x and y denote any points on any of the bisectors. Okay, we are letting x and y denote any point on any of the bisectors. Okay, so you know that these are the bisectors. So we either denote it here. So let's say x and y, or we either denote it here, right? So it doesn't matter where you put it, right? X and y, or we call here x and y. Anywhere you put it, we are fine. Okay, so one thing I want you to know is that what is making this formula useful is the word equidistance. The word equidistance. So let me mention it again. If we say equidistance, meaning that the distance of points from L1 is equal to distance of points from L2. So that is what is making this formula useful. Other than that, we don't really have any formula standard for this particular concept, equation of angle bisectors between two lines. So that is why we went to use the formula for distance of a point between distance of a point from a line. Okay, so basically that is the formula that is helping us to find an equation of angle bisectors between two lines. And the word that is making it useful is equidistance. Take note, equidistance. So equidistance means that the distance of a point from, let's say, line 1 is equal to the distance of a point from, say, line 2. Okay, so from this problem, we can say that our line 1 is this and our line 2 is this. Okay, so s plus y plus 2 equals 0 and s plus 7 y plus 26 equals 0, right? So from here, we compare this with the equation or the line equation of a line, right? The linear one. So that is x as plus by plus c equals 0, right? So we compare this equation with this and with that to find our a1, b1, c1. And okay, so now once we have all the parameters, we substitute it into the formula, right? So we're going to have our a1 here is 1 times x, b1 is 1 times y, plus c1 is 2, all over square root of 1 squared plus 1 squared. And that is equal to plus or minus of a2 is 1 times x plus b2 is 7 times y, c2 is 26, all over square root of a squared plus 7 squared, right? So we're going to have x plus y plus 2 over square root of 2, and that is equal to plus or minus of x plus 7y plus 26 all over square root of 50, right? And we know that this will be equal to x plus y plus 2 over square root of 2 equals plus or minus of x plus 7y plus 26 over square root of 50, right? So we're going to have, this will be x plus y plus 2 over square root of 2 was plus or minus of x plus 7y plus 26 over 5 times square root of 2, right? So when multiply both sides by square root of 2, then we're going to have x plus y plus 2 equals plus or minus of x plus 7y plus 26 over 5, right? So this comes here, we have 5 into x plus y plus 2 equals plus or minus of x plus 7y plus 26, right? So we expand this equals plus or minus of x plus 7y plus 26, right? So we equate this to the positive aspect, then we later equate to the negative aspect because this is plus or minus, so meaning we have two equations, right? So we have 5x plus 5y plus 10 equals x plus 7y plus 26, right? So that is the positive aspect. So we're going to have, this comes here, we're going to have 4x. This comes here, we're going to have minus 2y. This comes here, we're going to have minus 16 equals 0. So this is the first equation, okay? Then 5x plus 5y plus 10 equals negative of x plus 7y plus 26, right? So we have 5x plus 5y plus 10 equals minus x minus 7y minus 26, right? So we bring all this here, we equate it to 0. So we're going to have 6x plus 12y plus 36 equals 0, right? So this is our second equation and this is our first equation. So this can be for line 1, this can be for line 1, this can be for line 2, this can be for line 2. So that is basically the equation of angle bisectors between two lines, between the two lines. So these are the equation of the angle bisectors between the two lines from the problem. Okay, so this is the process that we go through to find the angle bisectors, the equation of angle bisectors between two lines. Okay, so that is basically the process. I hope you enjoyed the lesson. Don't forget to subscribe, share, like, and comment as you watch. I really appreciate your time. Please, on to the next video, keep learning and stay inspired. Bye-bye.